Good morning. Happy Wednesday. We are up to compound interest. Sorry. So compound interest is very different from simple interest. Compound interest is going to take that principal amount and add interest onto it as much as it's compounded. So it has to tell you how much we're compounding. Then the next time the interest would be figured by taking the principal and the interest. And this causes the interest to add up quickly. So simple interest is like a one and done. Compounding continues, which is worthwhile investments, but can also be risky at times. So this can be great if you're investing, like I was just saying, money, but it also can be not in your favor. Credit cards and debt, such as student loans. So those you end up paying more because your interest will be compounded. So our formula for compounded interest is the amount is equal to the principal times 1 plus the rate over time, over the number of times it's compounded, raised to the number of times it's compounded times time. So this is your total amount, your A. R is still your rate as a decimal. N is the number of times it's compounded. In a year. And P is still your principal, which is your money. And then time is T, which is still in years. So that's all our background information. And now it's just a matter of you plucking out the information and calculating whatever they're asking you to find. So Anna Maria deposited $400. So I pause right there. She deposited $400. That's my principal amount into a bank account that compounds her interest rate of 2.3%. After 5 years, so there's my time, what is the balance in her account if she makes no other withdrawals or deposits? The one word I neglected to underline was she compounds daily. Okay, daily. How many days are there in a year? So that is 365, right? 365 days a year. So take your formula and fill in what we have. Our amount is going to be equal to our principal, which was 400. 1 plus my rate, I have to bump it to the left, so 0.023 over what? N. N is my number of times I'm compounding, and that's 365. And then it is raised to time times the number of times it's compounded. So 365 times 5 years. This is all calculator. Put that all in your calculator. And you get $448.75. And that would be the total amount in her account after 5 years if she did nothing to it but let it compound. All right, so we want to compare the above scenario if she deposited into a simple interest. Totally different. When you see those words, simple interest, that is I equals PRT. All right, so they're saying the same amount of time, same amount of interest, the same money. So her principal was 500. Her rate was 0.023, and it was 5 years. So when you multiply that, you get 46. So she would have 446 if it was simple interest. Not much of a difference when you're not adding money to it. But the bottom line is, typically with a compounded account, you're continually adding to it. One and done. This will be continuous. So Julian invests $10,000, so that's my principal amount, into an account that pays 8.5%, so that's my rate, compounded quarterly. Quarterly means 4 times, right? Quarterly is 4. So that's 4 times a year. How much would the investment be after 4 years, which is your T? So again, as soon as you see that compound, that is this formula. And you're just going to go fill in what we've found. Our principal amount was $10,000. 1 plus my rate of 0.085 divided by 4, because again, it's compounded quarterly. Quarterly compound for 4 years. Put that in the calculator, and you're going to get $13,999.52. All right. So here we go. Let's continue this practice. So Allison wants to wants to have $20,000 to put towards the down payment of a house. So she wants this. So that's the amount she wants. She wants to do this in 4 years. So there's her time. If she invests in an account that compounds monthly, so how many months are in a year? 12, at a rate of 3%, how much does she need to put in the account? So they're asking you to find your principal. So again, here's my formula. And when you fill in what you have, this time you're looking for P. All right. So this is not a straight up calculation like the others have been. You're going to put all of this in the calculator, and you're going to get a crazy decimal. And since you're trying to solve for P, you're going to divide by that crazy decimal on both sides. And you find out that P comes out to be $17,741.07. So in order to get that $20,000 after 4 years, she'd need to initially invest $17,741.07. Okie doke. Number 5, a necklace is appraised at $500. If the value of the necklace has increased at a value of 5% per year, what was the value, 10 years ago? So you're looking backwards. So it's appraised at an amount of 500. That was its, that's the amount that they're telling me it's worth. So it's increased 5% per year. So your time is 1, right? It's only 1 year. And we want to know what its value was 10 years ago. So fill in what we have. Our amount is $500. That's what it was appraised at. We're trying to find out what that initial price was. So our rate was 5%. Our time, our compounding was per year. So 1 year. And we want to know what it was 10 years ago. So again, when you put this part in the calculator, you're going to get your decimal. And now when you divide by that, P is going to equal $306.96. So that was the value of that necklace 10 years prior. Suppose you invest your graduation money in a savings account that compounds your investment 4.2% quarterly. So again, our keywords there, we've got our rate. Quarterly tells me I'm doing that 4 times a year. If you invest, so that's your investment P, and leave it in there for the 4 years, which is your time, how much will you have? So this is a nice straight up calculation. We invested $1,285 at a rate of 4.2%. We're compounding it quarterly for 4 years. And if you just left it there, you'd have $1,518.74. All right, the last one I'm doing with you as part of your notes. Max has an option to invest his $500 into a compound interest account that has a daily rate of 2.1%. So daily, which is $365, at my rate of 2.1%. Or the other account compounds monthly, which is 12, at a rate of 3.5%. If he leaves the investment in there for 2 years, which account should he choose? So this is your comparison. So you're going to be doing this twice. All right, so for this one, we want to know our amount. Our principal was $500. Our rate is 2.1%, and we're compounding it daily for the 2 years. And the other one, my initial investment of $500 at a rate of 3.5%, but we're compounding it monthly for the 2 years. So put all that in the calculator. For the daily, we get $521.45. And for the monthly, we get $536.20. So this would be the best choice. You're going to get more money out of it. All right. So once you've got your notes and you've got everything taken down, now you've got practice questions. There are 8, 4, and then another 4 practice questions on your independent practice. So those are going to be due by Friday. Okay, so you got Wednesday, Thursday, and then they are due Friday. All right. Have a great day.